Hi everyone. Thank you so much for having me. My name is Mayowa, and I'm really excited to be here today. I'm an Android engineer at Premise Data, and I'm based in Lagos, Nigeria. So I'm having this call right from Lagos, Nigeria, and really exciting for me to do this with you all. So today I want to talk about video capture with Camera X and Jetpack Compose, and yeah, let's dive into it. So, why is this talk really necessary? And I just want to kind of like give a foundation to why I'm doing this talk. Sometimes last year, in my company, we had a feature request to build a video recording application, which is like the feature has like some video recording capability within it. And as at that time, the Camera X library was just at the alpha release phase, and also we had just started migrating to using Jetpack Compose within our application. So there were a lot of questions for me personally, which is how do I create a video recording functionality that is built on Jetpack Compose, considering that we're already gradually like implementing new features in our application on Jetpack Compose. So it was interesting, and there were a lot of quite a number of like challenges, limitations, and those challenges and limitations are the things that I want to address in this talk and tell us and show us like how we can go about it. On the high level, my expectation is that at the end of this talk, we'll be able to like have a general understanding of what Camera Hex is as a library, and also we would go through how to implement a lifecycle-aware component. So basically, uh, to implement a a Camera X video recording with Jetpack Compose UI, we need some lifecycle-aware component, and then I'll show us how we can do all of that. It's also very important that we know how to like interpret some of the new component that we're going to build, which is a lifecycle array component within a compose view. And then finally, we'll look at the permission handling for video capture. So uh, these are the things that we're going to look at the end of today's conversation. So I have the GitHub sample code already on GitHub. So if you want to grab this later on or during this conversation, please feel free to grab this GitHub sample code as well. As a format, in terms of the way I will go about this presentation, I'm going to run through this presentation via my slides that I have here, and also like just navigate to my Android Studio just to like review some bunch of sample codes that we already have and just walk you guys through the implementation details. So to start with, what is Camera X? It's basically a Jetpack library. That's what Camera X is. And what it does for us is that it gives us like these easy to use APIs to implement video or camera functionalities. You guys will agree with me that before Camera X, using Camera 2 APIs or some of the old camera libraries were really very exhausting. It was difficult. There were a lot of challenges. Challenges ranges from maybe like it's a device compatibility challenge. It could even be some issues around like having to just stale advice on what's the best way to even like undo a feature or even implement a particular feature or using the camera API. So before Camera X, we had a lot of that difficulties. It was pretty challenging using the camera library. But Camera X simplifies all of that for us. It gives us like easy APIs to write a video recording functionality, or maybe it's even like an image capture. The CameraX API gives us all of those APIs that makes it easy to implement. Just to mention, it comes in different modules, and there's some of the modules you see here. It has a camera lifecycle separate, and then it has a camera video separate, and then it has camera 2, which is just an extension of the old library, camera 2 library itself. If you're not going to do a video recording or whatsoever on the camera, I don't think you're not going to need a camera video module at all. But if you do a video capture, you're definitely going to need a camera model. So like I said earlier, it has four use cases, which I really like the way the Android team puts the whole overview of the CameraX API, which is, you can do a preview, you can do an image capture, you can do an analysis, and then we'll do the video capture. For this talk, we are just strictly focused on the video capture itself. So to give more like an importance to why this talk is really awesome, I want to kind of like backtrack us to what it would look like if we're supposed to implement a video capture in a non-compose architecture, in a non-compose system. And that's what I want to show us. And just briefly, I'm going to go into my Android Studio. Just feel free. The code that you see here, don't worry about much of the code that you're going to see here. Just focus on what I'm going to show you right now. So this is where I want you to focus on at the moment. Now, this code is written within a capture fragment, and I would also mention that this was not written by me. This was just a code that I grabbed from the code lab for Google. And in this code, what I just want to show us is how we would typically design a video recording capture or video capture implementation if we're not supposed to be within a compose architecture. And this is what we have in the Google Code Lab. This is the part that are very, very important, which I want to like bring out some key important things out of this code snippet that we have here. So in this code we have like a bind capture use case, and then in the bind capture use case here, we will notice here that it's referencing a capture view binding, which is a reference to an XML view, which is the preview element that we have here. So it requires a reference to that, and it's the preview element or UI preview UI element that we use to like show the camera preview when the user is about to like capture a photo or maybe like record a video. So number one, it requires like a UI element, which is a reference to it, which is the preview view itself. That's one. The other thing that we'll also notice here is if we come quickly down to this place, we'll notice here that before we can use the camera provider itself, we need to bind it to a lifecycle owner. And that's what is happening. So we need to bind the camera provider to a lifecycle owner, which is what we are seeing here. So that's another interesting thing about the implementation details that we're seeing here, which is the lifecycle owner that we're binding to is the fragment. In other case, it could be the activity, depending on where you are implementing the video capture or the photo capture itself. So those two things are really important, and those are the two things that I want to show us. So this is typically how we would do a video capture implementation in a non-compose, and this works fine. This is good. This is beautiful. It works pretty fine. And just lastly, before I leave this part of the code, you would also notice here that to start a video recording, we have this API that's been exposed, like start video recording, and then it uses some permissions as well that needs to be checked. And then you as well need to like just create a file that the video recording will be saved to. In summary, what we've seen here is that we are seeing that if we're going to implement video capture within a non-compose architecture, number one, we're going to need a view-based camera preview, which is the one that we saw in the code, which is the preview that is referenced within the activity or the fragment. So we will need that. The other thing is that it requires a lifecycle owner to bind to the camera lifecycle. In the case of the sample that we looked at, it was binding to the activity. It was binding to the fragment. It could even be the activity or whichever case. Also, it requires permission handling for it. If you did notice, there was some async API call in that code, and then it uses a future API, and then it also as well uses callback for to send recording updates and also like get the camera instance. So we can actually even see here that it does use some async API, which is the future API to get camera provider. So if we want to do this in a compose architecture, what are the limitations that we're already seeing? Number one, the limitation we are seeing is that we need a preview view to be referenced. Or let me put it this way. Number one, we don't have a Compose API for the view-based preview that we just mentioned about. So in an ideal world, we would reference the view-based preview, and then we will attach that to the camera provider. But in the Compose world, there is no Compose API for preview view. So that is number one, a limitation, and then we're going to address that. The other one is that it requires implementing all of this within a fragment, or maybe like implementing the details of the video capture within an activity. But what happens in the situation where we are in like a multi-compose UI single activity, where maybe our application is just a single activity and we have like stacks of compose UI? In order to like make your code base clean and all of that, you would want to avoid having to go to the activity or the fragment to put all the details or the implementation details of video capture within that. Whereas the UI sits in a compose UI that is far down the hierarchy of the view itself. Or maybe it's even the permission handling that needs to be done, because for permission handling, we have to handle our permission on our compose UI. This time around, it cannot be on the fragment, it cannot be on the activity anymore. So we need to take care of some of this limitation if we would have to go the compose way for video capture. So those things that I did just mention now, what are the ways that we can solve them? What are the approach that we can go about them? Number one, we could, for the view-based preview view, what we can do is to use the Compose Android View API to interpret between composable and the view-based preview view. We can use that, and in our code, we'll be able to see how we safely use that, and then ensure that the implementation is pretty smooth. The other thing around not having access to the fragment, or not being able to not being able to do the implementation details in the fragment, what we would do is that we need to create a lifecycle-aware component that observes the composable lifecycle. And if you backtrack to the code that I just showed, you'll notice that we actually do need a lifecycle owner. And the lifecycle owner that we were using was the activity or the fragment. Now that we need a lifecycle owner, which we're using activity or the fragment that we don't have access to anymore, we need to create a custom lifecycle owner that we can use. And that lifecycle owner needs to bind to the lifecycle of the composable that is calling it, or maybe the compose UI in this case. And finally, we can handle permission with their company's permission library. And then we'll also see here as well, like how we can abstract our permission implementation details in order to just take all of that implementation details from our view or view model or our view itself. And then we can also see how that abstraction is being done. So we know what to do in order to go the compose way in this system. Now, what does our architecture looks like for this? This is just a typical compose architecture that you'll see on Google Docs or Google links. It's everywhere. So this uses the state-driven unidirectional data flow architecture. So we have the view and then the compose screen. The compose screen emits events to the view model. Sorry, I said the view. I meant the view model. So the compose screen emits events to the view model, and then the view model implements the event, takes care of what needs to be handled or changed, and then it updates the state. The compose screen already is listening to state changes, and then UI gets updated or invoked. That is a typical compose architecture. For our video capture, we need to introduce two things which would help us achieve our goal of video capture implementation. The first one is the video capture manager that we will introduce. The video capture manager will eventually be the lifecycle aware component that we are creating to stand in place for our activity of fragment. So we will introduce that into the system. The other thing we are going to introduce is a permission handler. This typically, you can have this done whichever way you currently handle permission in your system, But yeah, this is just a permission handler just to show like we need to like handle permissions, like requests for the audio permission or camera permission before we do a video recording. Yep. So now that we know the details of what we need to migrate to the Compose architecture, let's see how our video capture manager would look like in terms of implementation details. I'm going to this. Yeah, so this is the sample code I created for this, and I'll go to presentation. Cool. So this is our video capture manager. The first thing that's very important for a video capture manager is that it has to be lifecycle aware. And to do that, we are leveraging on the lifecycle event API that's provided by Google. Once it does that, we can access all the lifecycle event changes within the application or within the composable that the video capture manager is binding to. So we can ignore some of the details that we have here, but we'll see here that we are adding the lifecycle to this, or we are adding the video capture manager as an observer to the lifecycle that is being provided to it. Another thing that we notice there is this is just using a builder pattern, or you can use a constructor pattern to like create your video capture manager. It doesn't change anything. It's just like the way I prefer to like create the instance of a video capture manager. So we need to provide a lifecycle to it. We need to provide a context and a lifecycle owner to it. So like I mentioned earlier, since we have a lifecycle owner for this, we would also have to like now observe some of the lifecycle changes. When we are implementing a video capture, we need to make sure that all our video preview binding is only done after the UI have been created. So basically, we need to like listen to an onCreate event for this kind of thing. And at this point here, you'll notice here that we are listening to an onCreate event. And I just want to like give you an overview of what we are doing within this highlighted code snippet. What I'm doing within this highlighted code snippet is just to like query the camera info to understand what capabilities does this camera, this hardware device support. Does it have a front and back camera lens? Does it support flash or touch, as the case may be? So that is just what this snippet here is doing. And the implementation details for that, you'll find it within the query camera info method I have here. So I have here a method that implements checking how to query the camera info, and then it provides just some camera info using an hash map. So this is actually like returns the camera info as an hash map in some case. And yeah, so that is everything this is doing. And just to like summarize this, it's just for us to understand that before we can use a camera within a device, we need to know that the device supports the camera, and we need to know the lens that it supports. And so we can appropriately set the preview that is right for the device. And the other thing here is that we are only querying the camera info after the onCreate lifecycle of the lifecycle owner. That is very important for us to do. And the final thing is that we need to like bind a camera provider to the lifecycle owner in order to like get the camera info that we're trying to query for. Yeah. Although there is I think there is like a simple API that would not require binding to the camera provider anymore, but that API doesn't simplify the details of the camera info, and that's the reason why I'm still like sticking to this approach in order to get the camera info of the device. Now, moving away from that, there are two things that are important within our camera video capture manager as well, which is having a preview, a view-based preview for the composable to bind to, and then for the composable to update when it needs to update. So because of that, we're going to create two APIs here, which is a show preview API. And this API is just returning a preview view itself. And the preview view eventually will be used by the composable that will be using the video capture manager within it. So the reason why we can't just have like a preview view sit within our composable is because before you will use the preview view, we need to do a couple of things. We need to like set the preview view to a preview use case. So we need to set the preview view to the preview use case. And also another thing we need to consider is that before binding a preview, we want to make sure that our lifecycle is at least resumed itself. And then we also want to make sure that we bind a video capture manager or a video recorder to the camera provider. So eventually, the preview view, the lens that we have decided to select, which is the camera lens, and also a video recorder use case, all of these would have to be binded to the lifecycle of the video capture manager using the camera provider API. And so once we have done all of this implementation, we know that we can guarantee returning a preview view that a composable can use within itself. Later on, we're going to see how this API, which is the show preview view, is being used within the composable. But these actually just abstract all of the implementation that we could have tried to put into within our composable, and then maybe like leads to some pitfall in this video capture manager. The other thing that we'll know or we'll see here is the update preview. And for this is basically just calling the show preview in order to like maybe the user decides to like change the camera lens by tapping on the flip icon, or maybe like the user decides to like on the touch by tapping on the touch icon. Yeah, this is the API that we use to achieve that eventually. And you'll notice here that it's taking a preview state. And if you come to the preview state eventually, you'll be able to see that it just takes in some primitive parameters on, wait, what lens do you want to show? What do you want the flash to be on or whatsoever? Yeah, so that is like a big picture of what our video capture manager would look like. The other thing that I would just see here is that we'll see here that we're having some implementation details around, hey, we want to start a video recording, and the video recording returns a file part, as a file, takes in a file part, and then we can initiate starting the video recording. Of course, the video recording in the Android API has a video recording listener that we can listen to in terms of updates, and then we can get those updates, maybe like the duration of recorded video, or maybe the video recording is paused or still playing. We can get those updates and emit the updates to the view so that the view can do what needs to be done. All of these are just API exposing some of the video recording functionalities. So this is like what our video capture manager looks like. And if you look at this is just like taking all of the details that we could have added to our activity of fragment, and then we're putting it inside a custom lifecycle-aware component. To summarize video capture manager again, it's lifecycle aware. We implement the video capture use case and the preview use case. We ensure that we expose API to get the video preview for this. Those APIs will be used by the composable that calls them. And we also have some callbacks to take care of handling camera capabilities like the camera info, or maybe like the recording update. And then we can send those callbacks to the view, which is eventually delegated to the view model. And then APIs for like starting, resuming, or stopping a video capture. All right, so this we have talked about video capture manager. Let's quickly look at our permission handler. I would not spend so much time on the permission handler because we could have it in our own preferred custom way. But let me just show us like what that looks like. So this is using the accompanies permission handler, and so we are just creating a class to abstract all the boilerplate of using the accompanies permission handler within your view. So if you have used the library before, you realize you have to like dispatch a couple of events and do those events repeatedly, and then have the API, which is the accompanies permission library, show the request for permission. If you look at this very well, this looks like a typical view model architecture, just for the fact that it is not extending a view model because it doesn't need to. And yeah, so this would just like have a couple of events, like we dispatch an event if permission is denied, we dispatch an event if the permission dialog is dismissed, or when a permission is required, or we dispatch an event as well. We can look at the composable. I'm going to just jump straight into this place. So the permission handler there was just more like a custom class that handles event and update state. That's what it does. But let's look at the composable for the permission handler, which is this. This composable is going to be used across any compose screen that requires a kind of permission. Now, this composable takes in a set of a that needs to be handled, and then it takes in an instance of the permission handler. Now we see here that we are using the remember mutable permission state from the library to check to get the state of the permissions. And then once the permission changes at any point in time, we launch this effect once the permission changes. So one event that will dispatch immediately the permission changes is a permission state updated event, so that the permission handler can update its permission state within it. And then other event that can be taken care of is if permission is granted after the permission state has changed, or maybe if a permission never acts dialog button is being tapped. So we need to dispatch those kind of events so that our UI can respond appropriately. The other part of this is handling the permission action. So there's a permission action like hey, we can request for permission now, or should we show a rational permission screen, or should we show a never ask permission again screen, which is like going to the settings screen or kind of action. So we take care of this also using a composable, but one of this composable one of the actions is actually within a launched effect, because it has to like reference the accompanies API here that we see here. But others can actually be just straightly other set of composable. This is a dialogue that I created. It's a custom dialogue, so it can be any kind of dialogue that you also want to add, or this go to settings screen can be any kind of settings that you also want to use, screen that you want to use. So basically, that's how we monitor changes in permission states, and then also take care of permission action using this handle permission request and this permission handler class that we have abstracted out. Now, what this would do is that we have taken away all the boilerplates that we could have added to our recording view model or our recording screen. We've taken all of that boilerplate and abstracted it into this place. And later on, we're going to see how we use this permission handler. So the next step for me is I want to take the view model. Now that we've implemented our video capture manager, our permission handler, let's implement our view model. Let's see how our view model looks like. Then finally, we can look at our composable, or how the composable looks like. So I can come here and just. So yeah, so this is the architecture for my composable. It's using a unidirectional data. Sorry, the architecture for my view model rather. It's using a unidirectional data flow just one single state, and then it also has events. It handles event, and then it also has effect that is being dispatched to the view. Effect are one of kind of action that needs to be taken care of, and state are persisted on the UI. So we have this being driven by the Android Flow API. So you see here that it takes in, I have a file manager for creating file, just in case I want to like create a file that will be used for recording. And then I'm also having the permission handler within the recording view model. Other ways, I could decide to have this permission handler within my compose screen, but I'm adding it to the recording view model because I want everything that is being updated on my compose screen, or I want, rather, I would say it this way, I want my compose screen to listen to just one state, which is the state that comes from my view model, which is the reason why I have this permission handler within the view model. So you notice there that what we're doing is just to like, listen to the state changes of the permission handler and then update that within the view model state. So we can listen to that and then update that within the view model state. That will just be fine. The other features that we see here is that now we see how we are dispatching events. We are handling events that are being dispatched from maybe the video capture manager or the view, and then we are taking care of them within this place. In a very typical scenario, what this will just do is maybe like let's say the flash icon is being tapped. Oh, the flash icon is being tapped. What was the current state of the flash icon? Was the touch state off? If it's off, turn it on this time around just by updating the state. So this is likely doing more of like a state update in some of the event handling. I want to backtrack a little because I did mention a case where we'll query the camera capabilities within the video capture manager, and we have what we call the camera info. Now, I want to show us this event here, which is one of the events that we have here, which is camera initialized event. Camera initialized event is an event that is being dispatched from the view, which proxy the video capture manager to the view model. And then we handle that event using the on camera initialized method that we have here. So you notice that this is just some bunch of logic. We are checking what are the infos about the camera lens. Does it support a back lens? Does it support a front lens? And then I can decide which lens I want to use. And if it doesn't, I can just use like the default. So I have this camera initialized as well. So these methods that we're seeing here, another method that we see here is on record tapped. Maybe like when the recording is tapped, let's say we come to record tapped here. For this case, we want to create a file when the recording is tapped, and then we would emit, this time around, we're not updating the state, we are emitting an effect called record video with a file path. And then I'll get to the details of why we need to like emit effect and not a state in this case. And that's because for this, recording a video action is a one-off dispatched action effect to the view, and we need to dispatch it as an effect, and then the camera can take care of all the recording action that needs to happen, or how the video is being recorded. We don't take care of the implementation details of the nitty-gritty of the implementation details of the camera X. That is done by the camera X. We just need to dispatch a record video effect with a file path to it. So basically, if you look at this is just on the high level a unique directional data flow architecture that listens to events. Those events can come from either the video capture manager, or it can come from the compose screen, and then it handles those events as we have here. So we see here that it's also handling some camera recording updates, like is there progress, like what's the current progress, is the recording paused, has the recording ended, and whatsoever. And in all of these, much of what we are doing is either we are updating the state, or we are dispatching an effect that needs to happen. For recording finished, we're dispatching an effect to like navigate to a playback screen for this case. So either ways, it's either an update that is being a state that is being updated, or an effect that is being updated for this. And that's because our view or our compose screen only listens to just these two things, which is state and effect. So how can we summarize the video capture view model? We can summarize it as a unidirectional data flow architecture, listens to UI event that has been delegated to it, and then it handles it. It handles this by updating the state that triggers the UI changes for the camera preview lens. We did see how we can change maybe like a user tap on a flash icon. All we just needed to do was like update the state, and then the camera preview will change to using maybe like it's the front or back camera lens. And then we use an effect to trigger actions like recording, post recording, and other UI side effects. So yeah, this is where we tie up everything, which is the video capture compose screen itself. And let's look at what that looks like. Mhm. So yeah, so this is the entry screen for video capture recording. So it takes in a recording view model as it would. But let's look at some of the things that we are declaring here. Number one that we have here, we created a listener that we need to listen to from the video capture manager. So we created this listener. We make sure that we are using the view model as the remember key. I think that that's just sufficient for this. And then every time the callbacks are being fired, we're dispatching all these events. We just looked at some of the events that were implemented in the view model. And so these are some of the places where they are being dispatched. The other thing is that we also need to, now that we've created a listener, now we need to like create an instance of our video capture manager. Like I mentioned earlier, I'm using a builder pattern for this. And then we can easily just like create the capture list manager here. And yeah, so for this, we'll notice here, this is why we are using the permissions, which is the video permission, sorry, the permission handler that we attach to our view model. So all of that implementation details that we abstracted are now used using just these two lines and one other line that I'm going to show us. And that line is just to decide, okay, what screen do you want to show for this specific screen in this case. So basically, we have abstracted the details of the permission handling, and then we can use that details by calling just this two method. Yeah, I did think about like, improving our permissions list, not just to take a string, but to take like a list of data class that will not just contain like the permissions that we need, but it can also contain like maybe the rationale that we want to display for that permission, or maybe it's the rationale that we want to display for that permission in that kind of situation. So we could expand the data class from a string here to maybe like a list of data class that is much generic. It will work pretty smooth like that. For now, I'm just using like a single rationale for all of them, which is a string from the XML. Now, let's go to the interesting one here, which is calling the video screen contents, which this is just how that is being called here. But one thing that you notice here is that we are wrapping this within a composition local provider, and that's because we want to provide our video capture manager via composition local. We don't want to pass it using uh constructor argument. Or we don't want to pass it to the constructor as an argument to the to the as a method argument. So, and that's because of video capture manager is a class. It's not stable. It's not a data class. It's not marked with stability. And so it's subject to causing a lot of recomposition within our composable. So for that reason, we're using composition local to provide our video capture manager. And that's the way we will be able to handle it. Other things that are here are just another thing you notice here is that I'm setting just those collecting the setting the data that I just need on my composable. Let's look at video capture screen. A video capture screen is just a check between should I display a permission request screen or should I display a camera preview if permission is granted. So that's just what this screen content is. And you're not notice here that this is doing a nullable check, and that's because if we realize that the camera lens, none of the camera lens is supported on the device, then we don't need to create a preview. You just leave it on a blank state. At this point here, I think this is just the most important part of this. Others that you're seeing here are just UI aesthetics for like showing an header with the flash icon and the close icon. This is showing a timer if needed, and this is showing more like a footer with like a record button or a stop button, as the case may be. But let's look at our camera preview that we have here. I mentioned earlier that this is using a I mentioned earlier that this is using composition local to provide our video capture manager. And in order to access a reference of the video capture manager, we will use this local video capture manager API that we created. And then I can show us later on what that looks like. Just a pretty simple API for creating that is being used for composition local provider. So we have this video capture manager created. That is fine. You also notice that our camera preview is taking just a primitive value itself. And this is very important because it's a camera preview. We want to make sure that the parameters that are being passed to this method are primitive parameters or stable parameters so that we don't have a case where this is always being recomposed, because if it's attempting to recompose when it doesn't need to recompose, then we would have a problem because it's video recording, and doing video recording we will try to always like update the progress. So during video recording our progress is always being updated, and if your camera preview is not created in such a way that it is recomposition safe, then you're going to have a problem. So with that said, we can just use the Android View interoperable API, and then we call the show preview with a preview state based on what we want, and then that will just be fine for this. And if we do need to like maybe like the user switches the preview view, maybe like turns on the flash, or maybe they flip the camera lens, then we can leverage on this update callback that we have here and immediately call our capture manager update preview API. So yeah, so that is how our video capture compose screen looks like. But let's kind of like summarize all of this. Number one is that we need to like create a listener and a video capture manager within the compose screen. When we're creating the listener and the video capture manager, if we do separate it, we want to make sure that we are using the same remember key for it. In our own case, we just use the ViewModel. Also, we are using the Android View Compose API to interpret the camera preview view within the composable. And as well, we are leveraging on side effect to start, pause, and then also resume a video recording. I'm not sure I showed the side effect part. Let me flip back to that a little, and then we can look at it. Yeah, so this is where we actually like handle the side effect for everything. We handle the side effect from the recording view model. So you'll see here that we are using the launched effect API, and we are collecting the event, and we are collecting the effect, and every effect that is being dispatched, we have a corresponding action to perform. So in our own case, if it's a record video effect, Then we call the method that we have within the capture manager, which is the start recording. If it's the pause recording, then we call the pause recording method. And all of that just wires up together and everything will be fine. Yeah, I just wanted to like reemphasize that recomposition is a big deal to avoid when it comes to video recording. And in order to do that, there are two things that are important. We need to use composition local to provide an instance of video capture manager to a child composable. Don't pass it via a constructor argument or a method argument instead. The other thing is passing stable parameters as much as possible. Keep it primitive as much as possible. So yeah, we've just gone through like video capture manager, which is awesome, and the video recording and all of that. But very quickly, we also need like a video playback. And I just want to like summarize that the idea of video playback or the idea of the video recording that we just went through, the video capture that we just went through, the architecture that we just went through, can as well be applied for video playback. Because for video playback, the video view is still view based as well. It's still XML based. It doesn't have a Compose API for it. So we still need like a playback manager that exposes a video view. But this time around, it doesn't need to do all like the dirty details of the video capture manager. It can just use a lazy instance of the video view. And also, we don't need a permission handler in this case. With that in mind, we can just like, this is what the architecture looks like for video playback, and that will be just be fine. Yeah, so that is all. If this will play, my time is up. I could have just like demoed it for you, but I'll just play this video just for us to see how this looks like. This is a reference to the code that we just went through, and this is how it currently looks like. So we just did a pause there, we played it back, we continued it back, and then we can use the playback manager. Yep. So that is it. Just to summarize everything that we've learned, we created a lifecycle-aware component as a substitute for the fragment or the activity, and then we handled all our video recording functionalities within this lifecycle-aware component. We also like exposed a saved approach to like interpret Android view and then the view-based camera preview, and then we use side effects for handling camera functionalities. We also discussed about like avoiding recomposition by using composition local and stable parameters.